Hi everyone, welcome back to another GCSE Physics webinar. Today's webinar is going to be on X-rays in medicine. So we're coming to the tail end of our waves topic now. We've previously been looking at electromagnetic waves, so we've covered the entire spectrum, what they're used for and why those radiations are used for the applications in specific. If you don't know me already, my name is Preshayla. I study physics at Loughborough University and it's my 4th year as a tutor. What we're going to cover today then is a recap of last week's webinar. So just looking at what we covered last week, communications, UV, X-rays and gamma, just because it's going to be important that we understand X-rays before we move on to the applications of X-rays. Then we're going to be talking about the process of taking an X-ray. Then we'll talk about radiation dose and how much is harmful. And then how can we use X-rays for therapy? So we're not only going to be looking at it in terms of taking images of the body, but also in terms of therapy. And then we're going to do actually a few quizzes today. We don't have much content to cover, and I thought it would be a nice way to wrap up electromagnetic waves. So they're quizzes that we've already done before, and we'll be doing 2 of those, and then we will get on to some exam questions. Okay, so what did we look at last time? Well, we started off by looking at radio communications. So what I said was that the left-hand side of the spectrum, so all those before visible light and up to visible light, can be used for communication. So that is their primary purpose. As we know, in a mobile phone, we use radio waves, and that is being constantly transferred between mobiles and mobile phone masts and satellites. Now, radio waves are, in this instance, an example of carrier waves, okay? Carrier waves. Now, they're called carrier waves because they carry a signal, pretty simple. But those carrier waves don't necessarily need to be radio waves. They could be microwaves, infrared, or visible, depending on their wavelength. The type of wave that we use, microwaves, radio waves, infrared, or visible, depends on A, how much information is in it, and B, how far does our signal need to travel? Okay, so how do we select the correct electromagnetic wave? Well, we need to think about how much information we need to transfer and how far our signal needs to travel. So then we said that the shorter the wavelength, the more information we can carry, the shorter the range, and the less they spread out. Okay, so these can have advantages and disadvantages. If we have a short wavelength, then we have a short range, and this has an advantage in local radio stations where we only need our wavelength to spread out in the surrounding areas. So the shorter the wavelength, the more information we carry. As we know, microwaves have a shorter wavelength than radio waves, and therefore microwaves carry a lot more information than radio waves do. So for this reason, we use microwaves for satellite TV. They can also travel in space and spread out less than radio waves. So then we looked at ultraviolet light, which is us now moving to the right-hand side of the spectrum. So moving past visible light into UV. So we know that the applications are tanning beds and fluorescent lamps, but why do we use ultraviolet as such? Well, ultraviolet as a radiation can be absorbed by a lamp and re-emitted as visible light. However, there are hazards, which are skin burning, skin cancer, and it's obviously an ionizing radiation, so we can really harm ourselves using these. Then we went on to look at X-rays. Now, X-rays are primarily used in medicine, as we're going to see later on, but why do we use X-rays? Why do we use X-rays for taking an X-ray? Why don't I use gamma rays for that exact same purpose? Well, high energy rays can be transmitted through the body with little absorption. Okay, so we want those X-rays to be able to get through the body with little absorption. However, they are absorbed by dense structures like bones, and more on that later. There are hazards associated with it, and they can cause the mutation of genes and cause cancer. However, it all depends on the dose of radiation, as we're going to see later on. Gamma rays are used for medical imaging. Okay, so radiotherapy, sterilization, and imaging, and they originate from changes in the nucleus of an atom. They are, again, high energy rays, which can be transmitted through the body with little absorption, and again, can cause the mutation of genes, and this all depends on the dose of radiation. Then we looked at, okay, how does basically a radio station work? So how does the microphone work? How does it get to our receivers? And how do we then hear it? So we looked at this 6-step process, which takes the sound waves and the microphone picks them up and transmits them in our transmitter, and that gets turned into radio waves through a modulator. Those radio waves then travel through the air into our radios, into our receivers, and then the receiver can then pick them up as sound waves. And I won't go into too much detail just because this is recorded, so it will be on YouTube, and the full explanation is on YouTube if you go onto the UV, X-ray and gamma webinar. This one will also be recorded so you can refresh, revise and get done any notes that you didn't. Okay, and then we looked at optical fibers. So optical fibers are a way of using visible light in communication. So we've talked about radio waves in communications, and we've talked about microwaves in communications, but how is visible light used in communications? Well, it's through these things called optical fibers. And they're very thin glass fibers which can transmit signals using visible light or infrared. They can't escape the fiber, so it's a really good way of containing information. When they hit the surface, they're reflected back into the fiber and can carry a lot of information because visible light has a shorter wavelength. Remember, shorter wavelength means more information. And they're much more secure than letting them roam through free space like radio waves and microwaves. So you're probably wondering, how does the optical fiber work? Well, an optical fiber would look something like this. This is an optical fiber cable. And what it does is it lets the light ray in, and it bounces that light ray back and forth throughout the whole optical fiber. And it's a really good way of transmitting a signal with sensitive information, such as your Wi-Fi. Okay, so that's all the content that we covered last week. So how do we actually take an X-ray? A lot of you will have had X-rays, and you probably have no idea how it happens. All you get at the end is your doctor showing you your bones fractured or something like that. Okay, so how does it actually work? Well, we have an X-ray tube. So we have a little tube where the X-rays are being created using electrons. And so those X-rays are created in that tube and pointed at the patient. Okay, so they're pointed at the body part where the X-ray is being taken. The photographic film is on the other side of the patient. Okay, so it's a nice photographic film which is behind the patient. So you've got the film, the patient, and the X-ray tube. So they pass through the body. These X-rays pass through the body. They pass through soft tissue, but they're absorbed by bone, teeth, and metal objects. So they pass through the tissue that surrounds our bone, but they get blocked by the bone. So actually, the image that we're seeing is not really the bone. It's the tissue around it. And because we're only seeing the tissue around it, we can therefore see where the bone is. So an X-ray is not really taking a picture of your bones. It's taking a picture of the tissue that surrounds your bones to show you where the bones are. And therefore, we call it a negative image. A negative image of the bones is formed. So, you know, in an X-ray, the background is black and the bones are white. Now, the bones are white because that is where the X-ray has been stopped. The X-ray has not been allowed to go through the bone, it's been absorbed by the bone. And that shows up as white on the photographic film. The black areas on an X-ray, however, are the soft tissue. So that is where the X-ray has gone all the way through the body and onto the photographic film, which is why it's showing up as black. So we're taking a picture of the tissue that surrounds the bone and not the bone itself. Now, if we wanted to take an X-ray of an organ, which does contain soft tissue, we need to approach it in a slightly different way. So as we know, X-rays go all the way through soft tissue. So an organ that contains soft tissue can be filled with a contrast medium. A contrast medium is a substance that absorbs X-rays really easily. So an organ that you might want to take a picture of could be a stomach, for example. So let's say an X-ray needed to be done of your stomach. What would happen is you would be fed a meal that contains this contrast medium. Usually this contrast medium is in the form of barium. So you'd swallow some barium and that would show up in your stomach. Now barium absorbs X-rays really easily and therefore you're going to get a really nice picture of your stomach because you swallowed the barium and it can absorb X-rays easily. So how do we stop X-rays reaching other parts of the body? How do we get just a picture of what we want, of what we care about? Well, lead plates are stuck between the tube and the patient, and these lead plates stop X-rays reaching other parts of the body. So how do we get this image on the photographic film onto our computer? How does that process work? So our X-rays have gone through the body and they've shown up on our photographic film. Now a detector contains a small device called a charge coupled device, or a CCD. The job of the CCD is to convert X-rays to light, okay? So the detector converts these X-rays into light. These light rays then can be transferred into electronic signals in the sensors that are sent to the computer for a digital image. So we go from X-rays to light to electronic signals, which can be shown up in a digital image. Okay, so radiation dose. Why is radiation dose so important? Well, throughout talking about UV, X-rays and gamma, I've always said that yes, they can be dangerous, but it does always depend on the radiation dose. How much of it are you getting? So X-rays, gamma rays, alpha, beta and gamma are all ionizing and dangerous. Okay, so if we remember, ionizing means that we add or remove an electron from the atom, okay? And if we add or remove an electron from the atom, then it becomes an ion. Now, ions are electrically charged, and if we have ions on our body, that can be really, really bad because we're changing the form of the atom into something that it shouldn't be, okay? So X-rays, gamma rays, and UV all have the potential to do this. Now, again, it all depends on the radiation dose. If you have one X-ray a year, you're going to be fine. However, if you're having a big exposure to gamma or X-rays or UV, then we can create damage. Okay, so The radiation depends on how long the exposure is, what type of radiation is being used, so is it X-ray, gamma or UV, alpha, beta or gamma, and the energy per second that is absorbed by the body. Okay, so it depends on these three factors. Now, alpha, for example, causes 10 times more damage than X-rays, even though you're being exposed to it for the same amount of time. So what that means is, if you go in for an X-ray, not going to take longer than a minute, usually. If you were exposed to an alpha source for a minute also, you would get 10 times more damage than having an X-ray. Okay, so it all depends on how long the exposure is and the type of radiation that we're using. High doses of X-rays kill living cells, but low doses cause gene mutation and cancerous growth. So we've already said that X-ray can be used for imaging, which we know, but it can also be used for therapy. X-rays can destroy cancerous tumours in the body. And thick plates between the X-ray tube and the body can stop X-rays reaching healthy body tissues. A gap between the plates allows those X-rays to reach the tumour and the tumour only. X-rays for therapy are shorter in wavelength than X-rays for imaging and carry much more energy. Low energy X-rays are good for imaging because they're absorbed by bones and teeth but pass through tissue and gaps. Low energy X-rays don't carry enough energy to kill tumours. So what you need to know from this is that higher energy X-rays are good for killing tumours. Lower energy X-rays are good for imaging. Okay, so low energy for imaging, high energy for therapy. And shorter wavelengths for therapy and higher wavelengths of X-rays for imaging. Okay, now that is all the content for today. And I'm going to take some questions now. So if you guys do have any questions, as always, put them in the chat, put them in the Q&A, and I'll get to them. Can be about X-rays that we've covered today or anything to do with electromagnetic waves. Ria said, how would you get an ion in your body in the first place? Okay, so if you were exposed to an ionizing radiation, so ionizing radiations could be microwaves, radio waves, ionizing radiations could be UV, gamma, or X-ray, or alpha, beta, or gamma. Okay, so they're all examples of ionizing radiation. Now, if that ionizing radiation gets into your body somehow, if you're stood next to a source, or if you're if you're exposed to nuclear radiation in a nuclear power plant, for whatever reason, if there was a nuclear explosion, you would be exposed to this ionizing radiation. This ionizing radiation gets into your body and it removes or adds electrons to the atoms in your body. And if this happens, your atoms will become charged. And that is not what we want. So if we get ionizing radiation in our body, we create ions. Is 2 X-rays a year harmful for you, or is it still okay? Absolutely, 2 X-rays a year are fine. Okay, there are people who go for X-rays every month. They are fine. It's all about the dosage, so how long you're having your X-ray for. You wouldn't want to have an X-ray for really longer than an hour, and you don't. The X-rays only last maximum 5 minutes. Okay, so no 2 X-rays a year would not be harmful for you. You would be absolutely fine. Okay, any other questions? How many X-rays in a year becomes dangerous? Now, I don't know the exact answer for this. Just have a quick Google and you'll be able to find out. Yeah, I'm not a doctor, so I don't know, but I imagine it would be a lot. Okay. So it says, I've just put it into Google, and it says that 10,000 X-rays in your lifetime could be harmful. Okay, so if you have 10,000 X-rays, that's when it starts to get harmful in your lifetime. Yeah, so 2 X-rays a year is not going to do anything. Okay, it doesn't look like there's any other questions. So what we'll do is we'll start with the quiz from 2 weeks ago. So this might be tricky. Don't worry if you don't remember the content. It was 2 weeks ago. And it is basically just talking about the spectrum. So lots of different things to do with the spectrum and a bit on visible light. So make sure you remember which has the longest wavelengths, which has the shortest wavelengths, and therefore the frequencies. Okay, so if you guys could please join this quiz, we are going to do the quiz from 2 weeks ago. So you want to type in joinmyquiz.com into your browser. You can do it on your computer, you can do it on your laptop, iPad, smartphone, whatever. Type that into your browser. You don't need to be on the Zoom window for this to work, so you can click off the Zoom window. You don't need to see my face. You can just type in joinmyquiz.com and type in the game code. If that's not working for you, I'm going to put the link onto our Zoom chat so that you can access it through there if you want. So there's the link on the chat. Hopefully you can all see that. I'm just going to answer Ria's other question, which was, do people have X-rays just as a checkup or only if they think they have a broken bone? Really, really interesting question. So generally, X-rays are only done if people think that they have something wrong with their body. Yeah, so generally that's the only reason that they would be done. However, if they have had a previous operation or a previous injury, they may need to have one as a checkup. So for example, if someone had a spinal injury and therefore a spinal operation, they might have discs, metal discs in their back. If that happens, then they might need to have a checkup just to make sure they are still in place. Okay, we've got 14 of you on and 15 of us. So I think we'll start. Good luck, everyone. 12 questions, 30 seconds per question. They're all multiple choice. Okay, looks like all of us are done. We got a 69% accuracy, which is really, really good considering we did it 2 weeks ago. So well done for that, guys. Let's go through the questions then. So which of these isn't an electromagnetic wave? That's ultrasound. Okay, so ultraviolet and infrared are both parts of the electromagnetic spectrum. Ultrasound is not. Which of these groups has the highest frequency? That's ultraviolet. It's the furthest right on the spectrum. Okay. And which of these groups has the longest wavelength? So the longest wavelength is going to be the furthest left on the spectrum, and so that would be microwaves. Which electromagnetic wave is used in satellite communications? That is microwaves. Which of these types of radiations has the shortest wavelength? So shortest wavelength is further right, and the furthest right is ultraviolet. Which type of EM radiation travels faster? They all travel at the same speed. So gamma, radio, microwave, all travel at the same speed. Which word describes the process of giving out radiation? That's emission. What colour is the best absorber of radiation? That's black. What happens to the temperature of a body that absorbs and emits infrared radiation at the same rate? It remains constant. Reflection from a smooth surface in a single direction is specular diffraction, and reflection from a rough surface causes scattering, and this is called diffuse reflection. If all wavelengths are reflected equally, the object appears white. Okay, so let's start another one. Again, just go onto the same website, different game code. I'll put the link in the chat. You should all know how to access by now. And let me know if you have any problems. Okay, let's start. We've got all of you on.
Hello, I'm Sarah. Welcome to
Okay, looks like loads of you are done. So really well done. We ended up with 71%. Let's go through the answers. So what are waves used to carry a signal called? Carrier waves. So carry a signal, carrier waves. That's all it is. The type of wave used to carry a signal depends on how much info is in it and the sound it makes, how much info is in it and the distance needed to travel, or how much disturbance is in it and the distance needed to travel. That is how much info is in it and the distance needed to travel. Which of the following is a consequence of having a short wavelength? A short wavelength is the more information it carries. So the shorter the wavelength, the more information it carries. Radio waves between 1 and 100 meters are used in local radio stations, and radio waves longer than 100 meters are used for international and national radio stations. Which of the following is a use of UV light? Tanning beds. What makes X-rays suitable? They are easily absorbed by dense structures, as we know now. Where do gamma rays originate from? That's changes in the nucleus. What type of EM radiation do optical fibers transmit? That's visible or infrared, as we saw today. And why do optical fibers carry more information than radio ones? Well, they're shorter. They have a shorter wavelength. And I know I've got to show you the leaderboard last time, so I will show you smiley face, PC, and then, I don't know, and Max Kieran, who's from my small group tutorial class as well. Well done. Okay. Now, we can do another quiz about what we learned today, or we can do some exam questions. It's really up to you guys what we do. I'm going to open up a discussion on the chat. What do you want to do? Do you want to do a quiz to consolidate what we've learned today, or do you want to do some exam questions? Okay, looks like the quiz is winning, so we'll do that one. Now, this quiz is only 9 questions, so it shouldn't really take us too long anyway. Okay, same drill as before. joinmyquiz.com. Okay, let's start. Okay, looks like quite a few of us are done. 65% accuracy. When an X-ray is done, a negative image is taken of the bone. The job of the CCD is to convert X-rays to light. Okay, so the CCD converts X-rays to light so that we can see it show up. A contrast medium is just a substance that absorbs X-rays easily and allows us to take a good X-ray. Low energy X-rays are good for imaging. High energy X-rays are good for therapy. A common substance used for contrast mediums is barium. The radiation dose depends on these three, so the type of radiation that is used, how long the exposure is, the energy per second that is absorbed, and not the person that it's used on. X-rays for therapy are shorter in wavelength, and X-rays for imaging are longer in wavelength. So nice short quiz there. Now let's have a look at some exam questions. So what type of electromagnetic wave has the shortest wavelength? What type of electromagnetic wave has the shortest wavelength? Put your answers on the chat. What do you think it is? What has the shortest wavelength? Brilliant. Well done, Avni. Gamma rays have the shortest wavelength. What is one difference between ultraviolet waves and visible light? And there's loads of different ones that you can have here. What is one difference between UV and visible light? Okay, so UV has a shorter wavelength, good. UV has a higher frequency, and you can see visible light. Yeah, that's fair enough. You can have that one. Okay, now this next part of the question is a mathsy question, and it requires you to use our equation, which is V equals F lambda, where V is the wave speed, F is the frequency, and lambda is a Greek letter, which means wavelength. So even though we're dealing with electromagnetic waves, we still use this equation. So you've been given the speed, the wave speed, and you've been given the wavelength. What is the frequency? So the speed is 3 times 10 to the 8, and the wavelength is 25 meters. What is the frequency? Have a think, put your answers in the chat. What is the frequency? Okay, so if we want to find the frequency, then we need to rearrange our equation for frequency. So currently we have our equation V equals F lambda. Now we need to rearrange this for frequency. So we're going to divide both sides by wavelength so that we get frequency on its own. Now we can fill in the numbers. Frequency equals wave speed divided by wavelength. Wave speed is 3 times 10 to the 8. And wavelength is 25. So when we do 3 times 10 to the 8 divided by 25, what do we get? What do we get when we do 3 times 10 to the 8 divided by 25? We get 1.2 times 10 to the 8, okay? So that is the frequency of our radio wave. Now here is again the electromagnetic spectrum. The arrow in the diagram is in the direction of increasing what and decreasing what. What fills in those gaps? Put your answers in the chat, and I'm going to start doing bonus points in the quizzes for those who put the answer in the chat first and get it right. So if you put your answer in the chat first and get it right, you're going to get bonus points for the quiz, which could bump you up. Okay, well done, Avni. You are correct. So frequency, increasing frequency and decreasing wavelength. Avni, you get bonus points for next week's quiz. Okay, now this is talking about hazards. So what is one hazard of exposure to ultraviolet radiation? Ultraviolet radiation. What is one hazard of exposure to ultraviolet radiation? Skin cancer. Brilliant. Well done, Avni. Skin cancer is the key hazard for ultraviolet radiation. Okay, and then the next one, what is one other medical use for x-rays apart from scans, apart from CT scans? What's one other medical use? What's one other use, apart from imaging, apart from scans, what's one other use? What was one that we talked about today? We not only talked about imaging, we also talked about what? Therapy. Good. So well done to Santati. And what is a property of x-rays that makes them suitable for therapy? Why are x-rays suitable for therapy? Good, they are high energy particles. So X-rays are high energy waves that make them suitable for therapy, for killing off those cancerous tumours. Now we won't do another mathsy question, but I will leave them on the screen so that when you watch the video back, you can pause it and have a go at home. And I will zoom in so that you can see the numbers. So 3 times 10 to the 8, 2.5 times 10 to the 2, and again 3 times 10 to the 8, and 3.2 times 10 to the 13. So do have a go at those at home. This one is again about an X-ray of a human skull. Now you need to use the correct answers from the box to complete the sentence. So when X-rays enter the human body, soft tissue X-rays and bone X-rays, what goes in those gaps? So soft tissue transmits our X-rays through and bone absorbs them, okay, so that we get a negative image of the bone. The X-rays affect photographic film in the same way that light does. Okay, so X-rays affect photographic film in the same way that light does. Okay, now this one talks about doses, and this is the final type of exam question that you could get about X-rays. So it's talking about doses. So here the table gives you the part of body which is being X-rayed and the dose of the X-rays received by the human body in arbitrary units. So for a head it's 3, for chest it's 4, and for the pelvis it's 60. How many head X-rays are equal in dose to one pelvis X-ray? How many head X-rays does it take for one pelvis X-ray? 20. Well done, Daniel. 20 head X-rays is equal to one pelvis X-ray. So if one pelvis X-ray is 60, then we need 20 head X-rays, 20 times 3 to get 60, which is the amount for a pelvis. Okay. Okay, now finally, which one of the following is another use of X-rays, having already talked about imaging? What is another use of X-rays apart from imaging and scanning? So X-rays are also used to kill cancer cells, yeah? So imaging and therapy are our two main ways of using X-rays in medicine. Okay, so that's the end of today's webinar. I hope you guys enjoyed and learned a lot today. Don't forget to pause the video and reattempt the questions at home, and you can even reattempt the quiz questions if you pause the video as well. We'll be trying the quiz again next week. And moving on to, I believe, reflection and refraction. This webinar has been recorded and will be uploaded onto YouTube later, so you can refresh, revise, and take down any notes that you didn't get down. So I'll see you. Oh, one more thing to mention actually is the small group tutorials. So we do have small group tutorials running in tandem with these tutorials, which are large group tutorials. In the small group tutorials, you can talk to me and also talk to each other. So it's much more interactive, much more questions can be asked and we can get to know each other. I can get to know your strengths and your weaknesses and really help you in a more direct sort of way. So yeah, that marks the end of today's session, and if you would like to sign up for those small group tutorials, then you just need to go onto MyTutor groups and click on courses. And also, if you want any one-to-one style tutoring with a tutor like myself, then that's something that MyTutor offer. And you just need to go onto MyTutor, find a tutor, and you should be able to find a tutor that suits your needs. Thanks for watching, guys, and I'll see you the same time next week. Bye.